I'm going to create a plane. Now, in case I go to my lights and I add, for example, a target spotlight, I would see, of course, the effect of that light on the plane. Now, if I selected the plane and went to modify and changed the length and width to make my plane bigger than the cone area projected by the light, I'm not going to see the effect of the light properly projected on the object in the viewport. For example, here I see a very low resolution projection of the light. Of course, if I render this, I'm going to see the proper effect. Now, one way to see it properly in the viewport is to select the plane and increase the segment count. So now whenever I do this and I take my light and I move it around, of course, I would see the proper area where the light is showing. But for now, to keep it speedy, I'm going to go back to a lower value. Okay, now, if I wanted to see what the light is showing me, I would go, for example, to my left view, right-click, and choose Views and Spot 1. And if I press F3, I would see what the light is shining on. So, for example, if I had the light coming through a window, and I wanted to see that if the light is actually coming through the window and which objects it's showing me, what I would do is go to this view and then arc rotate and zoom in and out in the light view so that I know what the light is going to be showing. And here I would see it in the perspective view. So this is the best way really to know what the light is showing you, by manipulating the light view. All right, so now I'm going to remove these objects again and go back over here. Now, we're going to discuss the light parameters now and see what each one of those parameters does. First, I can turn the light on and off. By turning the light off, I do not delete the light. But when you deselect it, you see a black color for the icon of the light, and this means that this light is off. Now, when I turned it off, everything got dark because the default lights in Max are now replaced with a light that has no intensity, and therefore everything is dark. Now, if I uncheck targeted, it won't have a target, and therefore, to change the orientation, I would have to rotate my light. Because whenever it is targeted, I change the orientation of the light by changing the position of the target. So this is by moving the position of the target. But whenever it's not, I have to rotate the light. If I move it, it does not change orientation. Okay. Now, of course, I can change the distance of the target by going like this here and re-getting that. It's not very important. Okay, now this is important here. Shadows. And we have several types of shadows. And if you have some plugins installed, in my case, I have the Ornatrix plugin and the V-Ray plugin. These would add additional shadows to your lights. Otherwise, you're going to have these ones, from advanced ray trace to ray trace shadows. And we're going to talk about all of them. Now here I have a global settings checkbox. If I check it and I create another light, all the lights are going to have the same shadow type because I have global settings on. So if you want to give all your lights the same type of shadow from here, from this list, you use global settings on. But most probably you would not want to do this. So it's advisable not to check it because sometimes you want to give this light a certain type of shadow and another light a different type of shadow, as we're going to see next. So it's best really to keep it unchecked. In case you get a problem where you see that all your lights have the same types of shadows, it means that you have global settings on, which you have to remove. Now, if I go to Tools and choose Light Lister from here, so let's say that I have a few more lights first. If I want to be able to modify a selection of lights at the same time, which are not necessarily instances of each other, because these are not. So if I uncheck, this one will not be affected. It's not an instance. So if I still want to change the properties of multiple lights at the same time, I would go to Tools and Light Lister, and this will show me a list of all my lights, so I can give them shadows if I like, whichever ones, and change the shadow type and change the color of the light, all in the same interface, so that you don't have to select different lights. So this would make your workflow very fast. Is it clear? Yeah. So it's tools, light lister from here, and you have the possibility, for example, if you want to change just the omni lights, you would select them like this and choose tools, light lister, and choose selected lights only. So now it will no longer show you the properties of your spotlight. If you choose all lights, it will change. If you choose general settings, these are the settings that will be applied to a light that you're going to create next. So normally you would work with all lights or selected lights. Now if you want to select a light, you can select it from here. So in case you want to work with the spotlight and you had the omni light selected, you can go here to make it selected, and then you can see the properties of that light. And you can, of course, rename your lights to anything you like and change the multiplier and so forth. We're going to talk about the rest of the parameters next. Okay, so this is a fast and efficient way to edit multiple lights at the same time. So I'm going to delete these now and go back to the parameters of the spotlight. So now we know what these parameters do. Now, in case I have the color and the multiplier. Now, the multiplier, we're going to also talk about the exclusion in a second. The multiplier can go to any value you like, but you should never really go beyond the value of 1.5 because it's going to render your scene very unnaturally bright. The color, you can choose whichever color you like from here. Now, this color here is very different from the color there. So let's choose green here just to make things different. This color is the viewport color, and this color is the light color, which means what? This means that this color of the light is going to light up the scene with green light. But what does this color do? Let's say that this is the viewport color. Let's say that I had a few other lights. This applies to any object, not just lights. So here I have 5 lights. And if I selected, for example, these two, I can go and change their viewport color. I'm going to select this one here and change its viewport color. So now, when I render, they're still going to render as green because the viewport color has nothing to do with the light color from here. But what does it help me with? These colors help me with the selection. If I go to Edit, Select by Color, and I click here, both these lights are going to be selected. If I go to Select by Color and I click there, both these lights will be selected because they have the same viewport color. So the viewport color is just there for selection and not really for rendering. I'm going to explain about the exclusion and inclusion. So first, I'm going to delete this light and create a light that goes down like this. And of course, it's going to cast shadows, and I'm going to make it grayish for now. And I'm going to place an object between that light and the box. So I'm going to create another box here and place it up there. Okay, so now, whenever I render, of course, this is going to cast a shadow, and therefore I'm not going to see the box underneath. Now, let's name our objects properly. I'm going to call this box obstacle, and I'm going to leave this set to box 1, and this plane is going to be called the ground, just to be able to select things easily with their names. So now, I'm going to select the light, and I'm going to go to Modify, and here I'm going to click on the Exclude window. Now, this would let me select objects to be either excluded or included for the light calculation, either in illumination or in shadow casting, or in both illumination and shadow casting. And here I have a selection set that I can use. We'll talk about this in a second. But first, if I want the light to go through the box, I would say exclude the box from the light calculation. So if I select the obstacle and go here and choose exclude from both illumination and shadow casting, and I render, actually it is there, but I cannot see it because of the yeah, I'm going to put it there. So if I render now, it's going to look black because it's not really being lit. So what I would do here is exclude shadow casting and not both illumination and shadow casting. That way it will be lit by the light, but it will not be casting any shadows. But does the other box cast shadows? Yes, it would. So if I move it up above the ground, I would see that yes, it does cast a shadow because I did not exclude it from shadow casting. Now the same thing can be done to inclusion. So if I had here a sphere, and I base it to pivot, put it exactly resting on the plane, and I create an omnilight and placed it there, and here I would say this time include the sphere for illumination and shadow casting, and I rendered this, only the sphere will be lit by this omnilight. So if I color let's color the sphere gray so that it's neutral in color, and change the color of the light to red. Now here in the viewport, because exclusion and inclusion don't work, you have to render to see the effect, I see that the whole scene turned red. But when I render, I would see that only the sphere turned red because of the inclusion. So this is how I would use include and exclude. Now down here I have a selection set, which means what? It means that if I had a few teapots here, and I made a copy, let's say 5 in total, and I selected them, here I can go and type in the name for this selection set. So I'm going to name this teapots. Now the selection set would let you select your objects very easily. So now I named the selection of teapots. So if I go here and click on teapots, they would be automatically selected. So if I had a room with 5 chairs and 10 tables and 5 windows, for example, I would create a selection set for all these so that I can easily select them. So now I can select the light and go to include, and down here I can choose teapot and push it in so that also the teapot will be affected by the red light. The decay is the diminishing of the intensity of the light with distance. And this is the way real lights work, because a real light that I place in this room would never light a room in another building, because the light intensity will decrease with distance. Now it can decrease in 2 ways. It can decrease according to a straight line, like this. So this is the highest intensity, and with distance it's going to decrease in a straight line, or it can decrease in an exponential line like this. So the further you go away, the less and less you're going to have a light intensity, but at this area you're going to have the highest intensity. So it's not linear as it is over here. So this is called an inverse square decay type, and this is called a linear decay type. So you don't have to worry about this, but know that real lights decay using an inverse square equation. So if I go here, I have inverse, which is what I showed you, the straight line, and the inverse square, which is, for example, 1 over distance would be just the inverse. 1 over distance squared would be the inverse squared equation, for those who like math. Now, if I selected my light and I rendered, I will see that the light here is shining in the directions. Just change the color so that we have an even distribution. Okay, so here I have the light shining here, and because it's an omnilight, it's gonna show me a circular spot, and the corners will have this natural darkening around them. So what I would go here is choose inverse and render. Now whenever I did this, I have nothing now, and I have this new sphere that shows, and this is the distance. Now if I increase that distance, I'm going to see more and more light showing here. Of course I should render from this view. If I turn this to inverse square, I'm going to get less light. But this will give me a better result because of the natural darkening of the corners. So whenever I'm looking at a room, for example this room, you'll see that the corners are darker than the walls. And to get this effect, I have to use the inverse square. Now, if I want to place lights in that volume, and I deselected my light, I cannot really see the volume anymore. So to make it apparent, even when it's not selected, I would check it from here. So now, even if I deselect the light, I would still see that volume. So basically, you would need to use inverse square a lot, because lights don't really extend to infinity. They go to a certain extent, which is defined by this value down here. Another way to control the light is not through math with this equation, but through two values which are called, or actually four values, which are called attenuation. We have two things for attenuation. We have the near attenuation and the far attenuation. I'm going to delete the slide and explain attenuation with a spotlight that is volumetric, because that way we can really observe what's happening. I'm going to go down to atmospheres and add volume light. The reason I'm adding volume light is because I want to see the actual light to see what attenuation does. So here, let's hide unselected so that we only get the light here. If I render, of course, I'm going to see the red light, which is going to extend to infinity, which is not natural, of course. So here I have to use attenuation to attenuate the extent of the light according to some values that I specify manually, which have nothing to do with the intensity of the light according to the way it decays with distance. So this is a manual way of changing the light. The other one is physical. So here, first of all, why would I use, I'm going to discuss first far attenuation, and then I'm going to try and figure out a way why do I use near attenuation, which is not very common in life, because lights always shine from their source. You don't ever have a light that doesn't shine around its source but shines later. And this is what the near attenuation does, but we're going to find a way to make it useful for us. So, first, if I choose far attenuation, I get two new levels for the light, which are the start and the end. So now if I render with these, I'm going to see that the light is very faint. Whenever I have attenuation on, the maximum intensity of the light is going to be from the light source up until the end of the start attenuation. So this is 1. So in case I add a multiplier of 1, I'm going to have 1 here. Now, the far attenuation is going to be 0. And from the start until the end of the attenuation, I'm going to have a decreasing intensity. So this goes down from 1 to 0, and then you have no light whatsoever down here. So what I need to do in this case is increase the end of the far attenuation and render, and this is what I get here. So it's clear now what the attenuation does. It changes the extent where the light is going manually through seeing these spherical forms. Now, what does the near attenuation do? In case I had a projector, for example, the projector does not emit from a point. And there are no lights in nature that emit from a point. They don't exist. In nature, you always have something that we call an area light. The area light is like my computer screen. It's light that's emitting from a surface. You never ever have a light coming from one point. And this is the problem with 3D graphics. Most of the light sources that you have do emit from a point. So they are called point lights. All these lights are point lights, except for the ones you see here called mental ray area omni and mental ray area spot, which can be turned into area lights. But still there we're going to have some problems. So the way that light emits off surfaces in real life is that lights always emit from an area. That area being planar, like the computer screen, or a light bulb, which might be spherical, or the sun, which is also spherical, and so forth. So if I do use near attenuation now, remember that when you select the axis of the light, you select both the light source and the target, so you cannot go to modify and change them. Make sure that you select only the source to be able to do that. So here, in case I wanted to render, but I did not want to get this sharp point here, I wanted to get an area, this is when I would use the near attenuation. And I would go like this. Let's first increase the start of the far attenuation. I would go like this, increase that value a bit. Alright, so now if I render, I would see that this light does not emit off a point anymore, but it emits off a surface. Now of course it's a hack, but it's a hack that works because it creates the proper effect that this light is emitting off a surface and not really a point. But the effect of the light is still the same. This is really a visual way of representing it, but the effect of the light is still the same, except for the fact that if I had an object here, in this area, it will not be lit by the light. So if I go here and render the sphere, let's move it a bit, or actually change the view. If I rendered here, the sphere would not be lit by the light because it happens to be close. First, let's make it overshoot. I'm going to talk about overshoot in a second. It's not going to render because it's in the area where you don't have any intensity because of the near attenuation. So if I lower it down and render, here I would see that it is actually rendered because it's in the area where you do have intensity. Is it clear now? So it's not very useful, but it's useful in that respect in case you wanted to show the light emitting like this. Okay, so now create another plane here. And the show light cone, really, what it does is show the light cone whenever the light is deselected. Again, it's useful in case you wanted to place objects within the light cone whenever the light is deselected. But otherwise, you would uncheck it. Now, overshoot, what does it do? Overshoot is very important because let's say that I had here a few objects. If I rendered without overshoot, only the light cone will have light in. But if I have overshoot on, the light cone will not be considered anymore for the light emission. But if I check shadows on, the shadows will only be computed within the light cone. So the overshoot does not take into consideration the shadows. The shadows will only be available inside the cone, but it's just there for you to light up the scene globally without having to create many lights. So make sure that you understand that overshoot does not create any shadows outside the light cone. Now, I'm going to uncheck it, and here I have to look at the hotspot and the fall off. The hotspot is the volume of maximum intensity of the light, and the fall off is the limit of the light. So that if I make them further away from each other, I'm going to have a softer edge for the light. First, I'm going to make them closer to each other, like this, and then I will get a sharp edge for the light. If I increase the fall off, I'm going to have a much softer edge. Now, I can either choose the projection of the light to be a circle or a rectangle. So if I choose it to be a rectangle, I no longer have a circle, I have a rectangle, and this is going to be very useful for us because next we're going to create an example of a movie projection on a screen, and we're going to use that, and we're also going to see how we can fit the size of that projection to be the same as the size of a projected image. Whenever I select a shadow type, let's say I select ray trace shadows down here, the shadow is going to turn to ray trace shadows. So if I select anything else, like V-ray shadow, for example, I'm going to get the parameters for that shadow. So we're going to start off with the shadow map, which is the default And this is the oldest shadow type that was with Max. But this does not mean that it's the worst. So, when I select shadow map, the shadow map is not a real shadow. It's a map that is calculated by Max and is projected on the objects to give the illusion that there is a shadow. So it's not really a ray traced shadows. It means that it's not traced as a light photon from the light source down to the object. This is not what's happening. What's happening is that Max will create a map from the point of view of the light and project this map onto the objects. That's why we call it a shadow map. It's a map. And because it's a map, it has a resolution, which we can change. And as anything else, if this has a low resolution, the shadow is going to look bad. And if it has a high resolution, the shadow is going to look good. And also because it's a map, we can blur this map or change the color of this map and so forth. But we cannot visualize the map directly. We cannot open the map in Photoshop and do whatever we like with it. No. But we can have some parameters in Max to control this map. So, first, to make this very apparent, I'm going to create a sphere and place it here and render. So here now, I have shadow maps on, and if I zoom over to check the quality of the shadow, I would see that I have a nice shadow. If I zoom even more, I would start to see the breakup of the shadow surface. So this can be controlled, really. But if I had to zoom that close with my animation, I would have to increase the resolution of the shadow. But if I didn't have to take such a close-up shot, I wouldn't really have to worry about it because it looks good from a distance. Now let's say that we do something. Let's say we take the light and we move it up and we render. We're going to see that the shadow blurs because that same map is being projected over a bigger surface and therefore it's going to look blurry. It's the same concept as you open an image in Photoshop and you scale it up. All the pixels will blur out because you're stretching those pixels. So, we can use this a bit to our advantage because if we take this really up and render, we're going to see something that is called, or something that resembles, a phenomenon called ambient occlusion, which is something that we'll talk about in detail a bit later. But for now, this effect, which is having a shadow underneath a surface where you don't have a direct light. For example, if I place my finger on my table, I will see a very faint shadow underneath my finger because of the lack of light between my finger and the surface. That phenomenon is called ambient occlusion in 3D. Now, one way to fake ambient occlusion is to create a light and move it up to a distance so that you have these soft shadows underneath the surfaces. Of course, you would have to add other lights, but otherwise, this is one way to do that. Although it's not very advisable. So this is also a hack. It's not really a good way to do it. So, the lesson to learn is that the shadow map has a resolution which can be changed. So if you increase the size of that map, you have to increase, if you put the light away from the objects, you have to increase the size of the map to get a higher resolution rendering. So how do we do this? If we right-click here, we can go to shadow map parameters. And this is where I can play with the different parameters of my map. I have three main parameters to use. One is called the bias, the size, and the sample range. Now, the bias has the same usefulness as the near attenuation of a light, which is something that you would very rarely use. The bias would take the shadow away from the object. So we're gonna, I'm gonna demonstrate this with a box because the box has sharp edges. Now, if I take my light and render, here, if I zoom over a little bit, I will see that the light is not really starting from the edge of the box. it's a bit shifted. And this is what the bias value will do. If you increase that even more, the light will be shifted more. So this is to create a special effect in case you wanted to shift the light. But I personally never use it. So I always keep my bias set to 0. So whenever I do that, the light is going to start exactly from the surface. But I still have some problems here. Even if I set the bias to 0, I would still see that it's not a perfect shadow at the base. To get the perfect shadow, I have to increase the size of the map. So first, before I increase it, I'm going to decrease it. If I go to 128, for example, and render, I'm going to have a very low resolution shadow. Very low resolution. If I go to 1024, which is the 512 times 2, I'm going to get a better shadow. And now I see that it starts from the base as much as it can. And of course, I can go even higher. So now it's a very high quality shadow. Now, the sample range would define the blurriness of the shadow. If I set the sample range to 1 and I render, I'm going to have very sharp edges for the shadow. You see those cracks here? This is because I decreased the sample range. If I increase it to 8, the shadow is going to be a bit blurrier, but blurrier in a nice way because the way it looks is not bad. So you can increase the blurriness of the shadow by increasing the sample range here. So absolute map bias would mean that it's going to have an absolute value regardless of the distance of the light from the object. And two-sided shadows means that in case you had, let's say, a plane here, and you know that the plane only projects from one side, can be seen from one side unless it has a two-sided material. In case I don't have two-sided shadows, it's going to cross it. In case I had two-sided shadows, it's not going to cross it, and therefore hit it from the side where it's not visible. I want to create a TV screen set, let's say made out of 25 screens, and all those screens emit light on a surface, and at the same time all these screens show the same image. So all these TV screens would complete the complete image. Each one will have a section of that image, and all of them would emit light on the surrounding. So what I'm going to do first is model 1. So I'm going to create a box here and set the dimensions, say, to 80 by 80. All right. Now, I'm going to convert this to editable poly, and I'm going to select the edges, press F3. Let's say all the edges. Now, if I want to curve out the edges, this is not a chamfer box. In case I want to curve out the edges, even though I have a box, I would select the edges and I go to chamfer. If I choose a value of 1 here, I do get a chamfer, but it's one segment only. It's one edge. So I choose apply, and then I would enter half that value, which is 0.5, or a bit less, and press OK. And now I have the chamfering around this box here. And what I need to do now is select the whole element from down here and go down to smoothing and give the whole thing one smoothing group. So if I click on 1, all the box is going to have one smoothing group, and therefore I'm going to have blending between the different polygons. So I'm going to select this, and I'm going to inset inwards a little bit, and then bevel inwards a little bit. So that would be my screen. Now, what I want to do is this. I want to have multiple screens, horizontally and vertically, and they should all display one complete image. They should not all display the same image. Okay, first, I'm going to create a material for the plastic material for the parts outside the screen. So I'm going to select the screen and press Control I to select the rest of the polygons. And I will assign a material, call it black plastic. Okay, this is assigned. If I look here, I see those triangles around the material. This means that this has already been assigned, so I don't keep pressing assign all the time. It's not going to do anything. You just assign once, and whatever change you do is going to stick there. So for now, I'm going to make it dark, and then I'm going to select the screen. I'm going to call this screen and assign it. For now, I'm just going to make it blue, but later I'm going to give it, of course, a movie to display. Okay, so this is what I have so far. Now I need to create this as an array. And we're going to use the Max 7 array feature that would create a preview of your arrays. So I'm going to choose Tools, first select this, Tools and Array. Tools, Array. Now, first I'm going to click on Preview. And I'm going to move this horizontal in the x-axis by a value of 80 centimeters, because this is the distance of one screen, and I can decrease the amount from here. So with the Max 7 preview, array preview, you can really visualize what you're doing with the array. Now, I want to create vertical ones, so what should I do? To create the vertical arrays, I'm going to click on 2D and specify the count. Let's say 5 total, as a total. But this time I want to move up in the z-axis. Yeah, exactly. Again, 80. If I wanted to create in depth, I would also choose 3D, and I would increase the Y value. But in this case, of course, I don't want to do that. But if I did, I would go like this. So this is the array preview, which is very functional in Max 7. So of course, I just want it to be 2D now. And I'll press OK. If I now I want to put a movie to be displayed on the computer screen. So I'm going to go to Maps and choose Bitmap and select an AVI file. All right. So by default, I get this showing on all the screens. This is not what I want. If I press play, I do have the animation because it's an AVI that I chose, but they are all showing the same image. I want to see the whole image on all of them. So it's very simple, really. All you have to do is select all of them and apply, go down and apply a UVW map modifier to the whole selection and choose, in this case, box. So now, whenever you press play, you're going to see the animation on all the screens. It's very simple, but it requires some thinking that the UVW map projector would project an image to a selection of objects, or to an object in case you had only one. It can project one image. So if you select all of them and apply the UVW map, all of them will have one complete image being projected. So this is the first part of the problem. The second part is rendering this and having light being emitted off that surface. What I want to do now is create a soft diffuse light coming out of the screen. And I don't want to see a sharp edge for the light. And I want to see the light intensity strong upon the base of the screen, which is what I have in this scene. So how would I do this? First, I'm going to go to my front view and add an omni-light in the center of one of the screens, which is here, and create instances so that whenever I change one, the others will change. So now I would select these and also create instances. So I can use also the array command that I used earlier. Okay, so now the trick is that, first of all, the lights should go inside the screens, because if they don't go inside, I'm going to have a shine around the lights. So this is the default here. I'm going to regain my default. If I just render this way, it's going to look very bad, really, because the plastic is being lit by the lights. And normally the plastic will not be lit by the lights because the light is protruding outwards and the plastic will not be that lit. So this is the wrong way, really. What I need to do is put these lights right inside the computer screens or the TV screens and tell them to cast shadows. First, if I don't tell them to cast shadows in our render, I'm still going to have a bad rendering because all the lights are adding up to the intensity and they're not hitting the borders of the TV screen. So I'm going to choose shadows on. If I choose shadows on, I'm going to have a very, very ugly rendering. And this is happening because of this. This light is hitting the surface of the other one and stopping there, and I'm getting the shadow maps here. What I want to do is that I want the plastic to hit the light and make it stop. But since the light is within the TV screen, it's going to cross it and hit the other side of the TV screen next to it, which is not what I want. I want the light to hit its own TV screen side. Therefore, I need to go to my plastic material and make it two-sided. Therefore, it's going to stay contained within the TV screen, but I will not set the screen to be two-sided because I want the light to emanate from that side. So the only way the light is going to go out is from the TV screen side, and the rest will be contained. So I will set the plastic to two-sided and leave the screen set to normal. Now, the trick to get a nice illumination before I get the nice shadows is that I need to use decay for light so that it gets high intensity close to the light and then decays with distance. So I need to go down to decay and choose inverse square. And here, right away in the viewport, you're going to get the proper illumination over here. But I still don't have the right shadows. So I'm just going to render now. I have ugliness in the shadows. The shadows don't look good, but at least I have the proper intensity at the base of the screens. And if I had a wall here, I would also have the proper illumination at the wall. But I still have to resolve the problem of the shadows. Now, whenever I use a shadow map, all the shadows are gonna overlap and create these striations in my shadows, which will look bad no matter what I do. So in case I change the one way to solve it really with the shadow maps is to increase the sample range, but it's still gonna look bad. The way to solve it is to use area shadows, because light is not emitting from a point, it's emitting from an area. And when I use area shadows, the shadow is going to get softer away from the distance. So close to the light source, I'm going to have a sharp shadow, but away from that light source, the shadow automatically will diffuse out, and therefore give me exactly what I'm looking for. Now, whenever I use area shadows, it's going to take longer to render, but the result is going to look perfect. So since they are instances, I'm going to go down and choose area shadows for my light. And I'm going to go down to area shadows. And here I have the parameters of my area shadows, which I can change. Now, since this is emitting as an area, I have a length and width for that area, which is 10 by 10 units here, which is 10 by 10 centimeters. So if I want this to be more realistic, I would set it to be 80 by 80, because this is the area of my screen. The dimensions of the area should be the same or close to the dimensions of the screen. The screen is a bit less than 80, it's around 75. To make it go faster, I'm going to set the quality to 3. Now, whenever I decrease the quality, I'm going to see grains in the edges of the area shadow. But for now, it's not going to really matter because I have many shadows overlapping and it's going to be diffused out. So I decrease the quality to 3 and I'm going to hit render. This grain is coming from the fact that I used a low quality. But at the same time, I have a very nice effect, which is the fact that whenever I have the border I have darkening, and whenever I add the light I have a bright area, which is exactly what happens in real life. So as a rule, whenever you have light emitted from a surface, you should use area shadows, and whenever the light is emitted from a very far distance, you can use shadow maps or ray trace shadows. But whenever you're looking for a realistic rendering, area shadows is the way to go. So this is how you would use area shadows to create a realistic lighting from a series of TV screens. If I want to create a stroboscope effect for the light, I can either do it by keyframes, or I can assign a controller to the multiplier of the light. The faster way would be to assign a controller. So I'm going to select my light and choose right-click, Curve Editor. And here I'm going to animate the multiplier. So I'm going to go to my multiplier here, because this is the thing I want to animate. If I set the multiplier to 1, it's going to have a full intensity. If I set it to 0, it's going to have 0 intensity. Now if I can fluctuate between these two intensities randomly, I would create my stroboscope effect. Now in case I want to do it randomly, I would use a noise controller. In case I want to do it in a predictable, repetitive, periodic manner, I would use a wave controller. So I'm going to start with the wave controller, which is periodic and repetitive. So I'm going to right click and choose Assign Controller, and here I'm going to choose Waveform Float. I'll press OK. So here I'm going to see that the multiplier is going to go from 0 up to 100, then go back to 0 and go down to negative 100, which is very far from what I want. I want the range to be from 0 to 1, back to 0 without going down to negative, because if it goes down to negative, it's going to darken up the area around it, which is not what I want. So, first of all, to set the upper value, I'm going to set the amplitude to 1. If I set the amplitude to 1, it's now going to go from 0 up to 1, down to 0, and then down to negative 1. So here, I need to remove the areas below. So, if I choose clamping, I can clamp the values which are underneath. If I choose clamp below, I'm going to remove the parts above. And if I choose add, I would add to my waveform. So every time it's going to increase in dimension. So what I need to do here is choose clamp above. That way I only have positive values, and therefore the light will not darken up my scene. The second thing I want to change, if I have a waveform here that goes like this is a sinusoidal waveform. In case I have a sinusoidal waveform, it's going to increase in intensity, reach a peak, and then go down. So the intensity is not going to stay static. With the stroboscope, you always have a static intensity. So it emits light, but always at the same intensity. Therefore, I should not be using a sinusoidal waveform. Instead, I would use a linear or square waveform, and that way it's going to keep the same intensity and then 0 and then regain that intensity. Now, what I want to do is make the waves closer to each other, and this is done with the period. The period is the time it takes one cycle to happen. If I decrease the period, I'm going to have more cycles, because one cycle is taking less time, and therefore I can fit more cycles within 100 frames. So if I take that period and lower it down, I'm going to put these waves closer to each other. So let's set it to 3. If I set it to 3, I'm going to have 33 light strokes. So that's it. I'm going to close this now, and I'm going to press play, and there you would have your stroboscope effect. So in case now I had a box that is turning, so let's choose rotate auto key and go here and give it a rotation, like a dancer, for example, on stage, and move it up. And render this, I would have the proper stroboscope effect. But of course I have to render this so that I can see it at full frame rate. Whenever two lights are instances of each other, when you select them both, you're going to see the parameters of both, so we can change. But if I grab these two, they're not instances, so I cannot see the parameters. So here, these 4 are instances together, and these 4, and so forth. But these 8 are not instances together. So 4 by 4, I have instances here. So now, this first one is 0.1. The second one, let's say, is 0.15. The second one, I'm going to make it 0.05 to create some contrast. The third one is 0.2, and the last one is 0.5. I might have to increase these values because I used decay for the lights. So let's do this. Let's give this a test render. So here I'm seeing that I have more darkness because of the decay. So here I can either increase the decay value, which is the distance that the light affects, or increase the multiplier. I'm probably going to increase both. But what I need to have is that at the start I should have a brighter appearance. So here I have some darkening because of the lights that I added here, which have a low multiplier. And at the mouth of the cave, I have a brighter appearance. So this is how I would create a realistic contrast inside my cave. And for now, all that's left for me to do is change the color and fine-tune the multiplier of the different lights that I have. But my setup is good, and I'm getting this result without actually using shadows, which would first of all speed up the render time. And this contrast is obtained because I used decay, which would create a volume inside which I'm going to have the light affect my region. So what I will do now is select these and set the multiplier maybe to 0.8. Select those and set it to 0.4. And here I'm going to play drastically on the color. So I'm going to make this really blue. I'll select these and make them reddish. And increase the multiplier to 0.2. I'm going to select these and make them greenish. So just create different moods inside. And select that one and make it dark brown to make the start really dark. Okay, so now I need to add my water surface. So the water surface is always planar. It doesn't go up and down. So I would add a plane here and raise it up. Now I want to see this in normal lighting without seeing the effect of my light. So I'll press Ctrl L, which will revert back to normal lighting. And I don't want to see the lights here, but I want them to have their effect. So I'm going to go to Display and uncheck Lights. So that way I don't get my scene cluttered with lights. So this is just for the display. And I'll go down to selecting geometry or all here. So I'm going to select my water surface and create a material called water. And I'll set the material type to ray trace. Now I'm going to set my diffuse color to total black because I want to give the water a color from its transparency. So I'm going to go to transparency and set the water color to light blue. Now, the brighter this color, the more transparent is your surface. If I set it to dark blue, it's going to be totally dark, and I'm not going to see a nice result here. So I'm going to set it to light blue for now. And the index of refraction is a number that refers to how this transparent surface refracts the rays of light. Now, the index of refraction of water is 1.33. compared to 1.5, which is the index of refraction of glass. And I'm going to increase a little bit the glossiness and the spectral level so that I have a little shine here, which would add more to my realism of my water surface. Now, in reality, I should not have these values. They should be 0 and 0. Because water should reflect whatever bright surface you have in the back. So I'm going to leave them like this for now. If I don't like them, I would remove them later. I'm going to assign my material And here, because I set the transparency to a bright value, I start to see transparency in the view. I might just lower this down so that I get the rocks protruding out of the water surface. And I'm going to set my background color to pure white for now. And I need to have a light coming through from the outside. So I'm going to add a target spotlight that goes down like this. And here I need to set shadows on. And I'm going to set the shadow type to ray trace shadows. And there, I'm going to set the intensity for now to 1 and set the color to bright yellow. And I'm not going to have it go straight into the surface. So here I'm going to right click and choose Views and Spot 1. I'll press F3, and there, whenever I change the direction of the light, I'm going to see where my light is shining. Now here, the surface is one-sided. If I want to see two-sided, I would right-click and choose Configure, and choose Force Two-Sided for this viewport, so that I see the borders of my cave. And there, I can appreciate more where this light is hitting, which is this surface. So now, if I press the Arc Rotate or Orbit tool in this case, I can see better where this light is going to hit the surface. So this part here is going to be brightly lit by this light. If I go like that, it's going to be this part that will be brightly lit. And here I would make it, instead of yellow, I would make it just bright blue, because my whole hue is bluish. Okay, so something like this is going to be nice. Save the file, and I'll give this a test render. Now, before I render, I also need to check Fresnel reflection for my water so that it reflects the environment properly, because water reflects the environment according to a formula which is built into the ray trace material using the Fresnel option. To get the Fresnel option, you have to check here once. When you check once, you can enter the value, but this will reflect planarly without taking into consideration the height of the geometry. So here I would check Fresnel, and I would add a bump map, which is a noise map in this case, and set it to fractal for now without increasing the levels. So just keep it low resolution here, or low detail. Save the file and give this a test render. This is the result that I get at the end of the render. What I need to do now is increase a bit more the contrast of the light so that here I have a bit brighter lighting. And then I'm going to take this to Photoshop and play with this a bit more to get a final rendering for this. Now, because I used the Fresnel type of reflection, I see that I have a nice contrast between the outside and the inside of the cave, and I have a nice reflection for the water surface. What I still need to work on is this area here. So I would select these lights. So I'm going to set back my selection filter to lights. I'm going to select this and up the multiplier to 0.4 and select that and up it to 0.37 and select the ones in the back and up it to 0.27 with a slightly bluish tint, something like this. Okay, so the other things I need to work on, yeah, I think that's it. Yeah, the other things I need to work on is to give some glossiness to the edges so that I get a wetty appearance for this. So I'm going to take this material and I'm going to up the speckle level and the glossiness like this. So if I increase or if I maximize this material, I need to make this as sharp as possible by increasing the glossiness value, because I don't want it to spread all around. So it needs to be sharp to give the impression of being wet. But to make it even more believable, I'm going to add a bump map here to break this up whenever this renders. So I'm going to go to my bump channel, and I'm going to add a noise map. Here I would choose fractal, up the levels, and go here. And I would see that now this is broken up to get my realistic wet look. And maybe I would tone down the bump a little bit because I have a lot of displacement. So I'd just go by 11 or 12. I'll save the file. And because this is my final render, I'm going to go to my render, and I would set the maximum to 16, and this is set to Mitchell, and hit render. We want to use Photoshop to create a haze effect, which we didn't have with the original rendering. So this is the original rendering, and here the start of the cave is very flat, and wanted to give it this effect here by applying some layer effects in Photoshop. So the first thing I'll do is regain my original image. So this is what I have at the beginning. The first thing I will do is duplicate my layer. And here I'm going to play with the blending mode to get the bright area showing up even more. So I'm going to choose screen, but screen would brighten up everything. First, I'm going to apply a blur filter to this new layer, and this will add haze. Now, I'm concentrating on this area here because this is what I'm interested in. And the rest, I want the haze effect to be reduced in. So I'll press OK, and here I'm going to click on the eraser tool, and I'm going to reduce the opacity, say to 30%, and I'll start to paint out the areas where I don't want the haze to happen. So let's say that I want the haze to be at the front side. I will paint out the areas where I don't want the haze. So here I can turn off the other layer and just paint out the haze like this. So that way only this part will have the brightening, which is the start of the cave. So here I can increase the opacity back so that I can remove everything altogether at once. The reason I reduce the opacity is that I want this effect to fade in gradually. So here I can go down to 50% again and go like this. So now I have a fading effect. So whenever I show this, this is with the haze and without the haze. And I clearly see that the haze effect adds depth and realism to my image. So in case I want to increase this even more, I can duplicate this layer one more time, and I can again paint out the areas that I don't want to be affected. For example, here and there, which are the areas facing the camera, or which are facing away from the light source. So that way, with this technique, I can paint which areas to be bright and which areas to be dark. So something like this. Now here I want this to be dark, so I'll paint out the light from this area, because this area is not facing the light all that much. And I'll do the same for the other layer. So that way I can really paint the contrast over my image. Now, if I want to preview this to see how it was and how it became, I would go back in history to the original image and then press Ctrl Z to see the difference. And here I clearly see that editing this image in Photoshop adds tremendously to the realism of the image. I'm going to talk about light projection now. So I'm going to create a plane here and a box. And I'm going to add a spotlight that goes like this. Now, whenever I render, I'm going to see the light cone projected on the geometry, but it's one color that is being projected. Now, to appreciate even more what I'm doing, I'm going to give both these one flat material, which is gray in this case, so that I just see the effect of the projection without having to worry about the color of the material. So again, I'm going to add the only light here with a very low multiplier so that I get even distribution of light. And there. Now, what I see projected is the light cone, and the color is that color of the light, of the target spotlight. Now, if I change the color, I would see that new color being projected. Now, this is not what I want. What I want is to project an image or a movie. So in case I was doing a theatrical projection, I would need to project an AVI or a QuickTime movie. So, what I would do in this case is go back to color of white and go down here to the advanced effects, and this is where I use my projector map. So I'm going to press M to open the material editor, and I will choose bitmap, and for now I'm just going to project a picture. So let's project the cave picture that we created. Now whenever I render, I'm going to see this picture projected over that surface. Now, what I can do here is, if I want to change the colors, is change the color, and that would blend between the projected map and the color. Now, in case you were doing a real projection, you would not do that. But in case you wanted to stylize your projection, you would change the color of the light, and that would influence the projected color. So for now, I'm going to keep it set to white. Now, if I was doing a theatrical projection, I would need this projection to be rectangular and not circular. So to do that, I would select my light and go down under Spotlight Parameters and change the spotlight to a rectangular spotlight. So now, whenever I project, I have a rectangular projection, which is what I want. But the problem is that this projection does not take the proportion of the plane over which it's being projected. And this is something that I have to fix. There are two ways to fix it. I can either fix it using a bitmap. So I can click on bitmap fit and select my bitmap like this. But this does not really fix it, because this takes the proportion of the bitmap and projects it on that surface. It did not take into consideration the size of the plane, which is something that I want to change, that I want to take into consideration. When I chose bitmap fit, it took the aspect ratio of that bitmap, which is the height, which is the width divided by the height. In my case, it's 800 by 600. So if you divide 800 by 600, you're going to get 1.33. So here, my aspect was set to 1.33 instead of being 1, which is the default. So you can do that in case your image had the same proportion as the surface over which is being projected, which is in this case this box. But since it doesn't have the same proportion, I need to find another way. And this other way is this. I'm going to go over to my front view. I'm going to play with the aspect ratio, and I'm going to increase it until I have the same proportion as my surface over which it's being projected. So here, I took my aspect and I changed it by increasing that value so that it has the same proportion as the box it's being projected on. But it needs to be smaller than the box and not bigger. So here, what I need to do is lower down the fall-off value so that it's smaller than the actual geometry. Now I need to play with it a bit more so that I get a blurry effect at the end here. So I would reduce the hotspot value so that the edge becomes a bit blurry, and maybe reduce a bit more the fall off. So the bigger the distance between the hotspot and the fall off, the blurrier is going to be the edge, and the more realistic is my rendering. Now, to prevent any distortion of the image, you need to have your original image have the proper proportion with respect to the projected plane. So this is something that you have to take into account before you apply this. So whatever footage you have, you would have to do this. But since we have this picture now, how can you fix it so that you don't have this distortion? So now, first of all, I have the nice blurry effect at the edges, which is typical to a theatrical projection. But I need to fix the projection of that, the proportion of the image, so that it doesn't get distorted that much. The way to do it is to open the material editor and to drag the projected image, which is this one here, onto there and choose instance. So now I'm gonna go to view image and I'm gonna take the borders up and down like this so that I get this panoramic view of my image, and I would choose apply. So now whenever I render this, I'm gonna lose my distortion. So in case your footage did not have the proper ratio of the projected surface, which is in this case around 2 point something, 2.3, you would take that image into the material editor, drag it, and go to view image, and make that image have the same proportion as the other one. Now, how can I know the proportion? Here I have the width set to 1 and the height set to point this value. So I'm gonna go here to my max script listener and choose 1 divided by that value and press enter, and this is gonna give me the result. So here in this case it's 1.6. So I need to make it even smaller so that I can get 2.3. So that way you can get the exact same aspect ratio that you're using here. But otherwise, so far it doesn't look all that bad. So by rendering again, this is what I get. What I want to do now is create the effect of dust scratches over my movie. And for that, I have to create several pictures in Photoshop and project them over my movie. But there is a rule to make this work easily in Max. Now, this is a sequence of images that were not converted in AVI. It's a sequence of images which I'm going to turn into a movie that plays like this. So, you can create as many images as you like, but creating 10 for now will be enough for us. I'll create a new image, 640 times 480, with a white background. And I'm going to use my brush tool to paint some scratches. They can be anything, so I'll just draw anything now. Now, to make this look a bit more realistic and photographic, I'm going to add filter, noise, and median. What this will do is blur out the edges so that whenever I have an intersection, it's going to be blurred more than when you have a straight line. Now, I can increase this value to get even more photographic edges. So here, a value of 2 gave me a nice result. Now, the more you increase the radius, you're going to get only the intersections. And this is the effect that we're looking for. Whenever you have an intersection, it's going to be more intense than when you don't have an intersection. But I'm going to leave it set to 2 for now. I'll press OK. And I'll choose filter and texture and grain. And I'll choose the grain type to be vertical. And I can play with the intensity to make it look like I have vertical scratches. So I'll choose File, Save As, inside my Maps folder here. I'll create a folder called Scratches. The reason I'm creating a folder is that I want to use multiple images and not just one image. Now, the requirement is that you should start the naming process by 00x, in this case 001. If you don't do this, Max will not pick up these images as a sequence. So if you just name them 1, it will not work, or scratch 1. So it has to be scratch 001, for example. Now, for simplicity, I'm going to name it 001, and I'll press OK, and this is a JPEG. And there. Now, I'm going to press Control Delete on my keyboard to delete everything. I'll paint some other scratches and reapply the effect. And I'll name this 002, and so forth until I've created the sequence. Now, in my case, I already created a sequence of 11 images, so I'm going to use that. So now, whenever I go to Max, I want to use that series of images as a sequence. So I don't want it to use one image. And I don't want to convert the images into an AVI, because that way it's going to take me longer to do that, in case I did that in After Effects or Combustion. And I'm going to have some loss due to compression. So the best way is to convert these into an IFL, which is an image file list, which is a format that Max takes whenever you have a properly numbered sequence and converts that into a movie. So to do that, for example, I'm going to go to bitmap for now, and I'll select the first one of my numbered images. So I started with 001 and I finished with 011. And here, by default, I have single image selected. If I choose sequence, it's going to give me 11 frames because I have 11 images, and the extension is going to be IFL, which again stands for image file list. So if I press view, I'm going to see one image, but here now I have the option to switch to the next image, like this. So this happens whenever you have an image file list. And that's it, I'll press open. Now here, I have a confirmation of the start and end time. And if so this is 0 to 10, so that would give me a total of 11, which is what I have already. And every nth frame, if you choose 1, it's going to display every frame. If I choose 2, I'm going to have a total of 5 frames, because it's going to skip one by one. And the multiplier, it's going to loop out the images according to the multiplier value. For now, I'm going to set it set to 1 because that will loop them infinitely. So I'll press OK, and if I press play now, I'm going to see the scratches happening as a movie. So now I'm going to use this on top of my projected map so that I get the scratches over my images. So I'll stop this and go back to my original file I had here. And to do that, I'm going to press M to open the material editor. And there's my movie that I'm going to project. So if I go here, I have a rendered movie of a shark underwater. So I'm going to apply these scratches on top of that. Now here I have a shark over a blue background with a material applied, and I have caustics coming down from a light source over that shark. We're going to see how to create caustics in another chapter. For now, this is what I want to apply the scratches onto. So I'm going to open that, and this is what I have. In case I render, I'm going to get just the normal rendering here. Okay, so here I need to set the environment type to screen, because so far it was set as a texture, and it should be environment and screen so that you see it properly projected on your screen. Okay, so now that I have this, I need to mix this with the scratches. So I'm going to click on bitmap, and I will choose, I have the option of choosing mix or mask. For now I'm going to choose mix, because I can define the color of the scratches as I like. And I'll choose keep old map as submap. Now this is the original movie, and there's the color 2 that I'm going to mix with. The mix amount is going to be the scratches that I created. So I'm going to click here and choose bitmap, and I'll select the image file list and choose open. Now I'll go to parent, and here, if I click here, I'll see that when I had the black colors, I can see the shark, and the rest is white. So I need to invert this. So I'm going to go to the image file list and then go down to output and choose invert. And now I will see the shark and the scratches on top. And the good thing about using the mix map is that you can go here and change the color of the scratches. So in case you wanted them black, you can go like this. For now, I'm going to keep them set to white because they contrast nicely with the background. One last thing I need to do is to blur out these scratches a little bit. So I'm going to go here to where I have these scratches and go to blur offset and increase that. And the more I increase it, the more blurring I'm going to have. So now it's a bit too blurry, so I'm going to lower this down to 0.01 approximately. Or let's say 0.005. Okay, something like this is nice. So now we're going to render this and see what it gives. We're going to render it with a small resolution so that it renders fast. First, I'm going to save the file. Now notice that whenever the scratches finish, they're going to repeat themselves because I have the playback set to loop. So whenever the first sequence finishes, it's going to repeat itself. And you can disable this in case you wanted to, and I'll show you how to do this in a second. Now, the more images you have for the scratches, the better you're going to have your effect, because people will not notice the repetition all that much. So here with 11 frames, people might notice the repetition. So in case you had 20 or 25 frames, it would give you a better result. So here, if I go down to time, I have the end condition set to loop. In case you set it to hold, it's going to hold on the last frame that you had in your movie, which is not what you want. So in this case, loop would give you a good result. Ping pong will play the movie in the proper order, and then it will play it back in the reverse order, and so forth. So in this case, loop would give me the best result. So let's see what we have now. So there's my movie with the scratches applied to that. Next, as a final effect, we're going to add rolling so that we give the impression of a really old movie, and flickering for the lights, for the intensity, so that we finish up this old movie projection effect. In this last part of the exercise, we want to create the flickering effect for the image and the rolling effect to simulate an old film. So we have to account for two things. The flickering, which is changing the multiplier of the projection of the light, and the rolling, which is changing the V offset of the map that has been projected. So how do we do this? First, what I had at the beginning was the mix map that had the movie of the shark and the image file for the scratches. Now, I'm going to delete the keyframes that I added. So far, the light has a constant multiplier, which means that I'm not going to have any flickering. Right-click Curve Editor. And I'm going to open the target spot, and I'm going to select my multiplier and choose Assign Controller. Now here, I'm going to choose a noise float. When I choose a noise float for the multiplier, it means that the multiplier is going to flicker according to this random curve that I have. Now, if I choose fractal noise, I'm going to have more roughness for the curve, so I'm going to have a more violent flickering. The important thing is to set the strength to positive, so that at all times I'm going to have a positive value and not a negative value, because whenever I have a negative value, the light is going to darken up the environment, which is not what I want. I want it to always stay positive, but go down to 0 whenever I have flickering. So I'm going to check positive and set the strength to 1, so that the maximum is going to be 1. So if I look here at the curve, it never goes down below 0. If I uncheck that, it might go down below 0 and therefore get negative lighting, which is not what I want here. So it should always be positive. Now the seed will just give you a random appearance if you don't like the way it flickers. The frequency is how frequent I'm going to have flickering. Okay, let's set it to 0.2. And the roughness, if I decrease that, so normally it's set to 0. If I increase that, I'm going to have more sharp edges for this. So I'm going to keep it set to 0. And the ramp in and the ramp out will fade in and fade out the effect. So if I want the effect to fade in, I would increase the ramp in value. And if I look here, I'm going to have a flattening of that curve for the ramp in. So let's say for 5 frames. And I'm also going to ramp out for 5 frames, so I also have a flattening of that curve. So the violent flickering is going to happen in the middle. So this is what the ramp in and ramp out will do. So whenever I close this and press play, I'm going to see the effect of the flickering in the viewport. So this is one thing that I solved. The second thing is to play with the rolling for my movie. So I'm going to go to the shark movie here. And normally this is set to 0. So I'm going to play with the W offset, because the V offset will, if I expand this, it will shift or offset the movie horizontally, which is not what I want. What I want it is to move up and down vertically. So this is exactly the effect I'm looking for. So if I go to a value of 1, it's going to go back to the same level. So you need to play with the values between 0 and 1, or 1 and 2, and so forth. So at the beginning it's set to 0, and I want to set keyframes here. So So I'm going to press auto key. Now, I want the rolling to start at frame 10. So I'm going to go to frame 10. I need to set a keyframe. The easiest way to set a keyframe just for this parameter is to increase that value and then decrease it. And then I would have a keyframe here. So at 10, I have a keyframe. I'm going to make the rolling happen, let's say, by 20, I want it to have rolled twice. So I'm going to set the W value to 2. So now if I scrub, it's going to roll twice between 10 and 20 because I set the value to 2. If I set it to 1, it would roll only once. Okay, and then I want it to jiggle the rolling. I don't want it to just stick there. So I want to go to frame, say, 24 or 25 and increase that value a little bit. And then go to 30 and decrease that value a little bit so that eventually it settles at 2. So now at 35, it's going to settle at 2. So now what I have is some bouncing for the rolling. So it goes up and then bounces a little bit and then goes down and then settles at 2. And all this is happening whenever the movie is actually playing. So I'm going to now go to frame, let's say 60 to have another roll, or 70. And again, I need to set a keyframe to fix it onto. So I'll go up and down, and that will add a keyframe for me. I'll go to 80 and let it roll once. So I'm going to go to 3. And then I'll do the same. So 85, I'll make it go a bit higher. 90, I'll make it go a bit lower. And then 95, I'll set it to 3. So now I've taken into account the rolling of my movie and the scratches and the flickering. So now whenever I render the movie, I'm going to have the required effect. Let's say that I had a plane here and I had a sphere on top. Now I'm going to choose base to pivot to place the sphere aligned to the plane. Now, if I had a real lighting situation, I would have shadows underneath the sphere over the surface coming from the environment that is lighting the scene. Which means what? Which means that if I was standing in the open atmosphere and I didn't have direct light coming to me, like the sun, I didn't have the sun shining on me, I was standing in the shade, I would still have some shadows underneath my figure. If I place my finger on the table here and I don't have direct light coming through the window, I'm going to have little shadows underneath my finger, even though I don't have a direct light source over me. And this is coming from the ambient lighting. It's going to come from either the skylight that would be surrounding me or from the ambient light inside an indoor environment, like in a room. So by default, ambient lighting has no effect in max. So if I try to render, I will not see any shadows underneath the sphere. So before global illumination was introduced, you had to simulate ambient lighting by adding a series of omnilights. So I would add an omnilight here, and I would choose shadow map on, and I would create a dome of lights. And I'll choose, of course, instance here so that I would be able to modify more than one light at the same time. So here, I'll be creating a dome of lights. I'm going to set my selection filters to lights from here so that I'll make copies. And I would scale down. The reason I'm modeling this light rig into a dome is that I'm trying to simulate a skylight environment because the Earth is spherical and therefore the atmosphere around the Earth is also spherical. Therefore, any simulation of that light should also be spherical to get a realistic result. So this used to be the old way of simulating global lighting. So here, of course, the light is very strong around the object, so I'm going to go to intensity and tone down the intensity. And everything will be toned down because of the instance. So if I rendered now, let's do this without shadows. If I rendered now, it needs to be lowered down even more. Okay, first of all, I do get global lighting, because everything is lit except for the bottom. So to light up the bottom, I would create a copy down here and choose copy instead of instance, because I need to lower the multiplier here even more. And these ones should not have any shadows so that they can cross the plane and hit the sphere, because I want to have light from the bottom. So now that I have this, I would select one of the lights and choose shadows on and render. So now I start to get the shadows that I'm looking for, but these shadows need to be arranged in a way so that we get a more realistic render. And the way to do that is to go down to shadow map parameters and play with the sample range value, because the sample range will blur out the shadow. And here, I don't want to have the impression that I have light coming from multiple sources. I want to get the impression that all of these are just one light source, which is the skylight around my scene. So here, I would increase the sample range. Let's go to 12 and see what happens. And now I get more blurring, and therefore this becomes more spherical, or more circular actually. And this is one way to simulate environment lighting. So whenever I have this should resemble a circle as much as possible by increasing the sample range. So whenever I have this, if I go to the multiplier and lower it down even more, now this would become my skylight light, which does have shadows underneath it. And now whenever I add another light source, which would be the sunlight, I'm going to have a very nice rendering of a daylight scene. So if I go here and choose target spotlight and give it an angle, I'm going to choose shadows on and ray trace shadows, because whenever I'm rendering in the direct light, my shadows are sharp. Therefore, I would use ray trace shadows here. And I would work on the color, very faint yellow, and the multiplier is around point, let's say 6. So now, whenever I render, I'm going to get an outdoor sunlight lighting. So this is how I would simulate a sunlight scene without using global illumination. Whenever I use global illumination, it means that these occlusion shadows, these are called occlusion shadows, are going to be generated automatically without having to place all these lights around. These lights are placed around because if I don't use global illumination, the rendering will go much faster, because whenever you do use global illumination, the rendering will become much slower. One of the benefits of using global illumination is that you're going to get those ambient lights or ambient shadows generated automatically. But you're going to have some artifacts here depending on the sampling that you use for the global illumination. The higher the sampling, the higher the quality, but the higher is the rendering time. By using this technique, which is a fake global illumination technique, we can get faster results, and we also get ambient occlusion, which is the fact that we are getting these shadows underneath the object. Now, the good thing about this is that whatever you place here is going to get the required shadowing. So if I go here and do a render, everything will have those nice shadows underneath it. But the only thing that we don't get, which we do get in global illumination, is called color bleeding, which is the fact that if you have a red surface, for example, let's say that this box was very saturated red. Whenever you do place this surface in the direct sunlight, some light from this, because the light rays are going to come down here and they're going to hit the surface and then bounce back down here. So you're going to have a red reflection on the floor without having the surface to be reflective. You're going to have some light reflection on the floor. This is what you get automatically with global illumination, but you don't get it here. So in case you want to get it here, in this example, you have to fake it. So we'd have to create an omni-light right in front of it, and I would make it reddish, so I can grab this color here and drag it to my multiplier or my light color, choose copy, and I would give it a decay so that it only affects this area, and lower down the multiplier and render. So here I'll be simulating a color bleed effect. Okay, I start to get some brightness down here. Let's make the color of this surface gray so that it's neutral. We don't see its actual color. I'm going to lower down the multiplier of the omni-lights. Take this and move it up and increase the start range and render. So now I want to use ambient occlusion to simulate soft shadows in my geometry. And then we're going to see how we can incorporate ambient occlusion into a still image so that the image would have, or the actual objects would have their own materials. Plus, we're going to add the ambient occlusion in Photoshop so that we mix both together and I get a map. I only see the maps, the max native maps, which are colored in green. Now the mental ray maps are colored in yellow, and you cannot see them unless you activate mental ray as your renderer. So you can activate it from here under assign render, or you can go to the preset from down here. And no matter what you choose here, it's going to be the same. So I'm going to choose mental ray. The first thing I will do is make sure that under indirect illumination nothing is checked, because this is something that we'll cover later. And under renderer, I'm going to decrease the sampling so that my rendering goes faster. So for now, I'll go to, let's say, 1/4/1, just for now. Now, the first thing I'm going to test ambient occlusion on is a scene that has greeble, because greeble generates a lot of detail in my geometry, and therefore, I can test the occlusion factor there. Once I have a good understanding of how ambient occlusion works, I can apply it to any scene I like. So, let's generate a surface. So we're going to create a box here and give it some segments. We're going to go and apply the greeble modifier. Now since I'm going to, okay, so here I'm going to increase the height so that I have a lot of protrusions, and maybe the height there. And maybe I can go down to my box and up the detail just a bit more. Okay, so now I have this. If I render with my regular material, I'm going to get no contrast between the objects. Now, the low detail, the pixelation that I'm getting is from the low sampling that I chose. So let's go to 1/4 so that we get something a bit better. Okay, I'm going to add a few lights around just to see the actual detail. But the lighting here is of no relevance, because what I'm working on is a material that will generate the occlusion. And I repeat that, the occlusion is the soft shadowing that you get whenever two surfaces are close to each other. So let's decrease the multiplier here and render. Okay, so here I have no contrast whatsoever, which is a very bad rendering, because all of these lights are lighting with the same intensity and they're not casting any shadows. But I want them not to cast shadows on purpose, because I want to get the shadows from the occlusion. So I'm going to assign a material, and I'm going to go to my diffuse map from here or from down here. And now I have the new mental ray maps, which are the yellow ones. And here I'm going to click on ambient reflective occlusion. So I'll double click on that. So let's see what we get just by adding this map. So if we render now, automatically we're going to have something different happening. We're going to see that wherever I have surfaces close to each other, I'm going to have automatic darkening of my areas. So these shadows that we spent a long time trying to generate with many omni-lights around my scene are here generated for free using the ambient occlusion map. So let's zoom over and see what's happening really between the surfaces. Now these shadows, I repeat, are not generated by the lights, because the only lights that I created do not have shadows on. All these shadows are generated with mental ray from the ambient occlusion map. So here, whenever this surface and that one are close to each other, I'm going to have the automatic darkening that happens in reality. And the further away, the softer is the shadow going to become until it dissipates at the end. And of course, with the ambient occlusion parameters that I have here, I can control the amount, first of all, of darkening. I can control the extent of the darkening, and I can control the resolution of the darkening, because if I zoom over here, I start to see some pixelation. And this is accounted for by the samples value down here. So the higher the samples, the better is going to become your rendering. So you're not going to get those grains that you get here, but you're going to get very soft and nice shadows. So what we learned here is that ambient occlusion generates darkening, automatic darkening between closed surfaces. If I had no surfaces that are close to each other, I'm not going to have that darkening. Now that we know what ambient occlusion does, I'm going to hide this surface, and I'm going to work on simpler geometry so that the render time becomes smaller. So here I'm going to have a box, and I'm going to tone down the segments, and I'll have another one here. I'm going to move this up. Now I'm going to remove these lights, because even if I don't have any lights in my scene, I'm going to use the default lights from Max. And I'm going to select all of these and give them the same material for now, which has the ambient occlusion applied. So I'm going to hit render and see what I get. So again, with ambient occlusion, I'm going to have automatic darkening between the two boxes, which does not happen with the native Max rendering. You're going to simulate this darkening by adding many Omni lights. So here, we get this automatic darkening because of the ambient occlusion map. So let's see what happens when we change the parameters. The first parameter that we have is the samples. If you decrease that, say, to 6 and render, it's going to render much faster, but I'm going to have a lot more grain, which would make my rendering unrealistic. So this is to test the occlusion, but not to make it as a final render. If we go by 12, again, we're going to have grain, because 16 already gave us grain. So 12, of course, will not give us a good result, but we're going to use that just to make our renderings go faster. This is where you control the quality of the occlusion. Now here I have two colors, which are the bright and the dark areas. The bright areas are the white parts, and the dark areas are the black parts. So if I take this and make it blue, I'm going to have the occlusion turn blue instead of being black. So this is to create stylized shadowing. And this depends really on the environment that you are using. Now you can map this. So instead of using just a color, you can give it a map. So if I go here and choose, for example, a gradient map, and give the gradient some colors, just any different colors now to see the result, and I render, I'm going to see that my occlusion would have the gradient applied. So this is used for stylized renderings, but not for realistic renderings. So in this case, I wouldn't use this for a realistic scene. So I go up and deactivate this by dragging an empty slot on top of it. So let's go back to choosing black, because this is the color that you would use most probably. The spread is the spreading of the ray. So instead of being sharp, it's going to spread and become softer away with distance. So if we go down to 0.2 and render, we're going to see that we're not going to have a lot of spreading. You see, everything gets darker between the different objects, because the samples are not being spread across the distance. So you can choose this to be any value you like, depending on the effect that you're trying to achieve. So here a value of 0.5 or 0.6 would give us a good result. Now the distance, maximum distance, if I increase it, if I increase that distance from 0, I'm going to restrict the occlusion to that distance, which is 1 unit in this case, which is 1 centimeter away from the box. So this is going to become barely visible. In this case, it's invisible. So if I increase it, I would restrict the occlusion to that distance. In this case, 8. So now it's a bit visible. So if you go to 22, it's going to be slightly more visible because I'm restricting the distance to that value. You see what's happening here? So I'm going to go to, for example, 77, just to make it a bit wider. And now, 77 pixels away, or units away from my object, I'm going to have the occlusion happening. If I go to 0, this would become unlimited, and I would have no limit to the distance. So 0 means that you have an unlimited distance for the ambient occlusion. It means that there's no limit. If you increase that distance, you're going to restrict the occlusion to that distance. So that way, you can make the occlusion affect certain objects and not objects that are further away from them. Now, here I have reflective. So if I activate it, I'm going to have the rays bounce up and down from these surfaces until I get a sharper or actually a darker effect, which is not always useful. But here I have different types of reflection. So I have reflective set to occlusion first of all, and we get much more darkening whenever you use it. But another one would be to use the environment reflection. So if I go to 1 and render, I'm going to get total blackness because I'm using the environment also to generate occlusion. And by default, the environment color is black. So if I go to rendering environment and I set the background color to something else like blue, and here I have my occlusion set to environment and I hit render, I'm going to have a blue environment around my scene because my occlusion now is using the environment. So depending on that environment color, you're going to have occlusion. And I can also map the environment with a map so that I get more interesting effects. So if I go to my environment and create a gradient here, so I'm going to hide the objects just to see the kind of gradient that I have. Okay, here I'm going to drag my gradient to my material editor, choose instance, and choose spherical, so that I have a gradient that is mapped onto a giant virtual sphere around my scene. And I would change the colors so that I have something that resembles a sky color. Very fast. And render. Okay, so this is the sky environment that I have. I can go and set the tiling in the V direction to 2 so that I get more bluish coloring here. So if I change the view here, I get this. So now if I unhide all, let's hide this, and I render, depending on this sky color, I'm going to have the occlusion happening in my scene. So this is one way to simulate skylight very fast and very efficiently using ambient occlusion and environment. Now, if you look at this picture here, we see that we have a few things in the way the lighting is happening that are not present with the default max render. First of all, if I zoom over this area here, I see that I have occlusion underneath the chair legs. And the whole area underneath that table is darker than the rest. Now, this scene contains two light sources. It contains a skylight source, which is lighting the whole environment, and it contains a sunlight, which is a target spotlight, to simulate the daylight system. Now, these two lights are these. This is the skylight, and this is the sunlight. Now, this is being rendered using mental ray, and here I used something that we call in mental ray final gathering, which is found under indirect illumination. Now, final gathering works according to a sample value that you specify, and this will determine the quality of the rendering. So here, if I zoom close, I see that I have some artifacts for the shadows. And these artifacts are being generated because of the sample value that I choose and because of the radii of those samples, which we'll talk about in detail later. For now, I'm going to start off with a simple scene and figure out how mental ray works with global illumination and final gathering. So first of all, to illustrate, if I have here this simple scene where I have this area that I need to be lit automatically using indirect illumination. First, if I have a light that's coming down, and I'm using the default scanline renderer from Max, and I rendered this, I will see that I have, first of all, let's cast shadows. I will see that I have total darkening here. But in case this was a daylight scene, I should not have total darkness here because of the light rays that would come down, hit that surface, and then bounce up and then down again, and so forth. Therefore, I should have a gradual darkening, but not total darkening towards the inner part. The default scanline renderer does not provide indirect illumination. It only provides the first light ray, which is called the diffuse illumination. So whatever is provided by this light is not bouncing through over the surfaces, and therefore I'm getting only diffuse illumination and not indirect illumination. And what I need to do now is find a way to activate indirect illumination. I'm going to delete this light, and I'm going to add a skylight here. And I'm just going to hit render. Now, whenever I add a skylight, all my scene will be lit globally, as if I had placed a dome of omni-lights around my scene. But so far, I have no shadows, and therefore everything is going to look flat, which is not what I want. So if I selected my skylight and I chose to cast shadows in the render, I would have a somewhat realistic skylight around my scene. Now this would take a bit of time to render, depending on the samples that I choose. But here I would see that even though I have a skylight, I have automatic darkening underneath that box here. This is similar to the ambient occlusion that we saw the other time. So now, if I had to simulate a daylight system, I would add a skylight, and on top of that, I would add my spotlight to have the sunlight shining through. So the first thing the skylight gave me is a global lighting around my scene. This is the first thing. The second thing, I have occlusion because of the shadows that are enabled here. But this is taking a bit to render. So we're going to cancel this and reduce the number of rays per sample, say to 5. Now this would render much faster, but I would start to see grain. So this is not really a good solution. It would be a good solution if in case I was previewing my scene to reduce the number of rays per sample, but for a final render I have to increase the rays per sample to 20 and beyond to get a grainless scene. So this is one way of getting a global illumination around my scene. But the only thing that I don't have here, I'm going to cancel this and I'm going to add a light. So let's choose target spotlight and shine down. The only thing that I wouldn't have is something that I call color bleed. For that, I'm going to add, give colors to my objects, saturated red. So if we add a light here, which is going to be the sunlight, I'm going to choose shadows on, and I'm going to set the light color to very bright yellow, almost white. And I'm going to leave the shadows for now set to shadow maps, just to make things go faster. So using this setup, if I render, I get very fast a daylight system, because the daylight system consists of two components. It consists of the skylight, which is provided by the skylight light, and the sunlight, which is provided in this case with by the target spotlight. And to get realism, I need ambient occlusion, which is provided by the shadows generated by the skylight. So this is the simplest way of creating a sunlight system. The only thing that I don't have, which should be required for a realistic daylight rendering, is the color bleed, which means that whenever I have a red material here, I should have a reddish tint here underneath it because of the light rays that would be bouncing. I do not get this using the default skylight system. So in case I required color bleeding, I have to use something else, which we'll see in the next example. One way to get color bleeding inside Max is to use the built-in light tracer. If I go to rendering and choose advanced lighting, I get to choose the light tracer and get the options from that light tracer. Now the light tracer is an advanced module where it can specify other options than the skylight provides you with, because the skylight only gives us a sky color. So if I choose blue here, I'm going to have a bluish hue around my whole scene, and whether or not to have shadows. Now in the light tracer, first of all, I can make it active from here. And down here, I have a color bleed value. Now the light tracer is not the most useful solution in Max for global illumination. Actually, it's the one that's used the least. But it's the easiest to set up, because if I want to use mental ray to simulate global illumination, it takes longer to set up. So here, it takes less time to set up. So I'm going to choose color bleed set to 1 here, and render and see what I get. I start to get something extra than what I did with the skylight by itself, and that is the smoothing of the shadow. So whenever I combine light tracer with the skylight, the shadows get smooth, and therefore the artifacts disappear. Now to get this look more realistic, I'm going to choose ray trace shadows for the rendering, so that my shadows get sharper. Because whenever I'm in direct sunlight, which is where I am right now, my shadows should be sharp. And here, I need to make sure that anti-aliasing is on. All right, so so far I don't have a lot of color bleeding, And this is coming from the fact that color bleeding comes from light bounces. So there's my light source down here, up here. It comes here, and it's going to hit that surface, and then it's going to bounce back. So in case I don't have any bouncing, I'm not going to have any color bleeding. To get color bleeding, you need to activate bouncing. And by default, bouncing is set to 0. So you have 0 bounces, and therefore you have no color bleeds. So I'm going to increase that value, but whenever I do increase it, the render time is going to go higher. So here is my bounces setting. I'm going to set it to 1 now and see what I get. Now, whenever I do activate the bounces, I start to get a brighter area here because the light is bouncing in, and I start to get some reddish tint here. Although it's not very visible, but I do have a reddish tint. So if I zoom over, I see that reddish hue here. Now, the more bounces I have, the more reddish this area is going to be. So let's set this to 3. And because of the light bouncing inside, I'm going to get a brighter area inside the occlusion. So now with 3 bounces, I get a much more realistic sunlight rendering, and I would start to see the color bleed, which is the reddish tint down here. So now it's very visible. Now in this area, it's not so visible because of the bright area coming from the sunlight. So if I take this and turn to the other side and give this a render, we should start to see some blue tint on the floor. So this is the way you should follow in case you don't want to use mental ray and you want to get a realistic global illumination for your scene with automatic occlusion and light bouncing or color bleeding. So here we clearly see the blue tint, and here we see the red tint around our objects. First, I want to introduce final gathering in mental ray. Final gathering is the process of having objects affect other objects in terms of ray reflection, which means that if I have a box over that plane and I move the box up, and I want this box to be a light source for any object in my scene, how can I turn this object, this box, into a light emitting surface? First, I need to give it the proper material to make it emit light. For that, I'll press M and I'll choose Get Material, and here I'm going to choose the architectural material. The architectural material has several presets, which we'll talk about. For now, what I'm interested in is the ideal diffuse preset, because this will make the object emit light according to the luminous value that I give it here. First, I'm going to assign the material to the selection, and I'll choose a color for diffuse color, or I can choose a map from down here. For now, I'll just choose a color, and here I can set the luminance value. So I'm going to set the luminance value to something like 1500. Now, if I render with the default max scanline renderer, I don't get the effect that I'm looking for. So this looks like a self-illuminated surface, and it has nothing to do in terms of lighting with respect to any other surface. I'm going to activate mental ray by going to the render scene dialog, and from here I'm going to choose under presets mental ray, no global illumination high. This means that there won't be any global illumination in this setup. Of course, I can change that. And I have a high sampling value. So I'm going to load this. The first thing I'll do is go to render, and here I see that I have a high sampling value, which will take longer to render. If I render this, I still don't have the effect that I need. But if I look at the edges of my objects, I see that I have a nice anti-aliasing to them. This would be good for a final render, but for a test render, I better set the minimum to 1/4 and the maximum to 1. So if I compare the rendering time now, this took 2 seconds with the high anti-aliasing. This would take 1 second now with the low anti-aliasing. Of course, the edges now are jaggy and rough, but this is good for test rendering. In the final render, normally I would go to 4/16. But for now, it's 1/4/1. Okay, so I still don't have the effect that I'm looking for. First, to get objects affect the lighting of other objects in my scene, I need to activate something that I call indirect illumination. And in Mental Ray, we have 3 things to consider when you talk about indirect illumination. We have caustics, which is disabled by default. You have global illumination, and you have final gathering. First, the first thing I need to do is activate final gathering, because this will make objects affect each other. This will make the lighting or the intensity of the material of one object affect another. I'm going to check enable first of all, and I will reduce number of samples, because if I leave it set to 1000, it's going to take a long time to render. So I'm going to go down to 100 for now, because I'm just testing this up. And I'm going to click on preview, because this will make my rendering go much faster. When I check preview, I have no pre-calculations. So whenever I press render, the rendering will start. If I don't check preview, the final gathering map will be calculated for a certain time, depending on the sampling values and the radii that I specify from here. And according to that, I'm going to wait for a certain time before the rendering starts. But for now, because I'm testing my scene, I'm going to check preview. And I'm going to hit render. So the moment I do this, I start to see that this object is casting light on the surface next to it. Now, if I want to modify the effect, I would go to the material editor, and here I can increase the luminance value. So if I set this, for example, to 4500 and render, I'm going to see that I have a stronger light emitted from that surface. But here I see that I have a lot of chunkiness in the sampling. And this is coming from the fact that I'm using low samples. So here, if I increase that, say to 300 and render, I'm going to have a higher quality. If I go to 700, I'm going to have yet a higher quality. Now, if I uncheck preview and hit render, here I'm going to see that the final gathering map is going to be calculated. Here, whenever I deactivate preview, I get a very smooth sampling for my final gathering. So now let's see if this affects shadows. For that, I'm going to create a sphere and choose base to pivot so that the sphere gets its base at the 0 level. And I'm going to assign a material and make it a bit bluish. And again, because I'm testing this, I'm going to check preview because this goes much faster. So whenever I hit render, I'm going to have the shadow calculated for the sphere, even though I don't have any lights in my scene. And the shadow color is affected by the color of the sphere, which is a bit bluish here, which is something that we have to fix, because in reality, a blue sphere does not cast a blue shadow unless it was transparent. But for now, I would accept it because of the color bleeding that I have here. And let's give this a test render with a high quality with no preview. But first, if I regain my last render, I see that I have lighting in my scene besides the lighting coming from this object. And this is because the rendering is also taking into consideration the default max lighting system. So to override this, I'm going to create an OmniLight here and set the intensity to 0. If I do this, no default max lights will take effect in the lighting. And now if I render, I see the pure effect of my object, because I'm not taking any default lights into consideration. And now I don't see that I have any wrong shadow colors. So the last thing for me to do at this stage is to uncheck preview and give this a final render. I want to assign a texture to my object. So I'm going to go to my diffuse map, and here I'm going to choose checker, and I'll select two colors. Let's say red and yellow. So here, I don't want to have the texture being mapped onto that surface, so I'm just going to apply a UVW map modifier, which is planar, and that will make the map project downwards like this. So whenever I render now, I'm going to see that the texture is actually casting light over the surface. So what I'm going to do now is take that object and rotate it down like this and place it down here to see exactly how this is affecting the object. This is similar to the screen setup that we had before by faking illumination from the screen. So if I render this now, I'm going to see that this surface is lighting the scene. So here I have yellow and here I have red. And here I have shadows. So let's test this with a higher sampling. So I'll uncheck preview and render. Okay, so here I see that I have a very high intensity. I should note that the bigger the light, the more intense the lighting is going to be overall in my scene, which is extremely important. So if I take, for example, this same object and place it here, the proximity of the object is going to affect the lighting considerably. So I'm going to check preview. If I render this like so, I have this lighting. If I take this light source and move it up, which is make it further away from the object, the lighting is going to decrease considerably, which is what happens in real life. But if I take that object and make it bigger, the lighting is going to increase. So one thing to note is that whenever you use final gathering, in other renderers, when you use global illumination, the size of the light emitting source, in this case a geometry source, affects the lighting considerably. The bigger the source, the bigger or the more intense is the lighting. If you don't want to see the light source in your scene, because this is really a huge light in my scene, all I have to do is go to properties and uncheck visible to camera, and this will not render that light source in your scene. So if I render the scene from here, I'm going to see that everything renders without seeing the light source. So this is how you would control the lighting over a big surface in case you had a restaurant, for example, to light, or a big interior hallway. This is how you would render it, with either one big geometry source or with multiple of those scattered around the scene. In this exercise, we're going to use final gathering to create lighting inside a box, which can be used for a bar or some parts inside a restaurant, for example. And then we're going to add metallic materials to these teapots. First, I'm going to reset my scene, and I create very fast that piece of geometry. So it's a simple box, which I'll convert to editable poly, and then I'm going to select these edges and connect them. So once I do this, I can select this polygon and inset it inwards, and then I can extrude it again inwards, and from the top view I can move it to the correct position. Now what I need to do is give this upper polygon the light material. So I'm going to select it, press M, and for that, again, I'm going to choose an architectural material with ideal diffuse. and I'll select the color that I want this to shine with. I'll assign, and I'll increase the luminance to 5000 for now. And then I'll press Ctrl I to select the rest of the polygons, and I'll give them, for now, a regular material. Can be anything you like. Now, I'll create some teapots for now. I'll use AutoGrid to place the teapots exactly over that surface. And then I'll select all the teapots, and I'm going to go to, again, architectural material, but this time I'm going to choose metal. I'll choose just metal for now. This will create a chromic effect for the teapot. So I'll assign the material, and I can brighten up the diffuse color to get chrome. Okay, so now that I have this, I'm going to activate mentor ray, lower down the samples, and preview what I have. So by default, this is the result that I get. Now, the reason this is lit is because I have the default lights being active. So I'm going to add an Omni light and deactivate it to remove the default lights. And that way, I get the lighting just from within my box. Okay, so again, as a rule, you always start with low sampling, and then you increase the sample, say, to 400, and you uncheck preview, and you get the required effect. So again, by unchecking preview, you get your perfect result. To create an exterior lighting in mentor ray, I have a simple plane and a sphere on top. Now, whenever I'm rendering an exterior lighting, I need to take into account two things, at least, and that is the skylight and the sunlight. And if I was doing a rendering where I need the skylight and the sunlight, plus some internal lights inside my scene, I also need to add extra lights for these. But in the simplest case, I need to have at least the skylight and the sunlight. We'll start with the skylight. So we're going to go here to lights and choose skylight and add this. So with mentor ray, the shadows are generated with the final gathering. So the first thing I'll do is change the color of the sky. We're going to keep it very bright for now. And in mentor ray, I'm going to activate final gathering and preview this. So here, if I go to rendering an environment and set my background color to blue, I can in fact take the same background color here to remove the black. I would get the required effect. Now here, what I see here is called occlusion. And the occlusion is generated from the spherical sky that is around my object. It's not a geometric sky. It's a skylight that is shining light from every possible direction around the scene. And that's why I get the automatic occlusion. Now, the first thing I can do is change the sky color. If I make it like this, I'm going to have a heavy blue, which is not something that I really want. So I would always keep it bright. Another thing I can do is add a map. So if I open the material editor and go here, for example, to bitmap, I'm going to select this sky color map and render. I'm going to have the rendering happen according to that sky color. So to edit this, I'm going to drag this over to the material editor, choose instance, and here I need to make sure that it's enderon and it's spherical. So if I render now, I get this. So again, these colors are generated from the color of the sky map. So in case it was different, let's say a sunset map, you're going to have an orange scene. So let's try this. But before that, I'm going to increase the tiling up to 2 in the V direction so that I get the proper effect, and I will set the V value to 0.25. The reason I'm changing these values will become evident in a second. Okay, so this is the lighting that I should get from this map. Now, why did I increase or change these values? If I create a sphere just to show us what we have as a sky map, and we assign a material such that we use that same map we're going to get this with the values that I chose. I'm going to reset those to 1 and 0. If you use the sky map as it is, I'm going to have the bluish part at the top, and the clouds are going to extend down. So that would not be a good projection of that sky map. I need to have the whole map mapped on the hemisphere, upper hemisphere of the sky. So for that, I'm going to choose 2 for the V tiling, and then I'm going to move the map up by 1/4, because here I have 1/4, 2 quarters, and 1/4 down here. So if I move it in the V-axis to 0.25, I'm going to have the sky map mapped properly on the upper hemisphere, which is what I'm looking for in my map that I used in the environment or in the skylight. So that's why I used 2 in the V tiling and 0.25 in the V offset. So having done this, I get the proper illumination from that map. So you're going to use these values every time you're going to use a map like this. So if I go now and choose another map, something like this. So if you render now, we're going to have an orange hue for our scene. So this is how we can control the lighting of a scene with a map. Now these are regular textures. Normally we use something extra. We use something called an HDRI map, which we'll talk about in coming examples. So for now, I'm not going to use any map. So I'm going to regain my skylight and uncheck map. And for now, I'm just going to use the sky color. Okay, so this is what I get. Now, of course, to fix the samples, I would go down and uncheck preview. Now, before I uncheck preview, I can also work on the radii of my samples, because if I don't choose any radii, the samples are going to be really chunky with the preview mode. If I check radius on, for here I'm going to go to 10 as the minimum radius. The radius is going to be the size of that splotch that you see here. If I decrease the radius, the size of the sample is going to decrease, and therefore I'm going to get a higher resolution. So I'm going to render now. Now with the size of 10, I still get big chunks of occlusion. If I go to 2 and render, I'm going to have smaller chunks, and therefore my rendering is going to be much better. We can activate 1 radius, or we can choose to have 2 radii, the minimum and the maximum. Now, the maximum radius is the size of the biggest splotch of occlusion that we can have, and the minimum radius is the size of the smallest splotch of occlusion that we can have. What I'm talking about is these. So if we zoom over, we're going to see that we have splotches here. Now, the smaller the radius, the more these splotches will turn into grain. And to remove them altogether, I have to uncheck preview. So, if I set the minimum radius to 0.1, and here I have the render time to be 8 seconds, if I render this, I'm still going to have 8 seconds, but I would activate the minimum radius to get finer detail. So I'm going to go down to 1 for the maximum radius, and this will make the occlusion even finer and therefore more realistic. Now, if I was on a hurry and I wanted to test the occlusion very fast, and the shadow detail was not very important for me, I would increase these values. So I'd go to 22, and that would render really fast in 2 seconds, but you would have chunky occlusion. So this is one way to control the sampling, to test the intensity of the lighting, because that way I'm not testing the quality of the occlusion, but I'm testing the intensity of the lighting by changing the radius. Now, To get a sunlight effect, or before that actually, in max 7.5 and on, a new parameter was introduced, which is the maximum bounces. And this is very important, and it was lacking from mental ray in versions before 3.4. With max 7.5 and on, we have the maximum bounce value that we can increase. Now, the more we increase it, the more time it's going to take to render, but the more realistic is the rendering going to be. So in this case, it's not going to matter all that much because I have a very simple setup, but at least I'm going to have a brighter occlusion in my scene. And I get the shadow right underneath the sphere. So you have to work on the bounces to get real lighting. For now, to make the rendering go faster, I'm going to reduce it back to 1. It was 0 by default. I'm going to put it up to 1. And now I'm going to add my sunlight, which in this case is going to be a mental ray area spot. So I'm going to shine it down like this. And I'm going to go here and choose views and set the area, the view to the light, and I'm going to changing according to what I want. Now in case I go like this part is going to be totally dark, or actually not totally dark because it's still lit by the skylight, but it's going to be darker than the size here. So I can zoom in or out in this case. I can zoom out so that the whole thing is inside my light cone, or I can move it up from here. So now that I have this, I'm going to select my light, go to modify, and I'm going to choose a very slight yellowish color for the sunlight. And I'm going to go down, and first of all, I'm going to deactivate area light parameters so that the rendering goes fast. And then I'm going to activate it. So first, I see that I have a very bright scene. Therefore, I need to reduce the intensity of my light. But otherwise, I have a very realistic sunlight effect. Now, all my materials are very flat now, and that's why the whole scene looks flat. So let's reduce, first of all, the multiplier. And let's deactivate radius so that this goes much faster. All right, so now I have something better. Now remember that I still have very generic gray color for the materials. So let's substitute this for something else. Let's put a bitmap and choose, let's choose this for both and render. So I get a very nice sunlight effect very fast with this technique. So the requirement was the skylight. If I deactivate the skylight, I'm going to lose the realistic sunlight. And again, I needed this spotlight to create the sunlight. Now the last thing I'm going to do is activate area lights. So I'm going to zoom over this area, scroll down, choose area lights on, and increase the height and width. Now here I'm going to choose, I can only choose disk and rectangle for this type of light because this is a spotlight. In case it was an omni light, I can choose sphere, which would be more appropriate for what we are doing now. So I'm going to show you this. If I choose mental ray area omni and I go down to area lights, here I can choose sphere and cylinder. So in case my light was spherical, I would choose sphere. And in case it was planar, I would choose rectangle from here. For now, it's not going to matter all that much, so I'm going to leave it as it is. Select this and increase the height and width value. So I'm going to go to 22 by 22. Now, in direct sunlight, these values should not be very high because the shadow is very sharp. But in diffuse light, which is in the shade, I would increase these values because I have a lot of soft shadows. So let's render this now. Now the moment I use area lights, my rendering is going to take longer. Now again, this is a very simple scene, so it's not going to take all that longer. But in case it did, and this is the area light effect that I got here, which is the blurring of the light away from the object. which is very important to get real sunlight. Now, a value of 22 here proves to be good. Maybe I would go to 25, but that's it. In direct sunlight, that would be more than enough. In case I wanted my rendering to go faster, I would go down on the samples, say to 3 by 3. I'm going to have grain at the edges of the area light, but that would be good for testing because it would take less time to render. Now, from a distance, it's not going to show all that much. If I zoomed over, it would be more visible. But from a distance, that would be a very good way to render sunlight in mental ray very fast. I'll start by building the hallway. It's 6 meters in length, 2 meters in width, and negative 10 centimeters in height, so that it goes underground. And I'll create the walls very fast using regular boxes. I'm going to set the height to 2 meters. I'm going to leave an opening through which light from the outside is going to come. And this is going to be a mix between skylight and sunlight. And this is the back wall here. And I still need the ceiling. So copy the floor, go to a height of 200, and set the height to 10. So this is what I have so far. Light is going to come through this opening. I'm going to make the opening a bit narrower. So this is 500. Light is going to come through this opening, and I'm going to shoot from the inside. So here I'll press Ctrl C to get a camera view and shrink down the lens. And this is what I have now. I'm going to give all these objects one material, which is light gray. And I'm going to place a sphere here. Now, I'll give the sphere the same material. The situation I want to create is to have skylight go through and light up the whole scene. So I'm going to use mental ray, I'm going to use final gathering, and I'm going to use global illumination, which will create the ambient lighting inside the scene. Now, the first thing I will do is create skylight. So I'm going to go to lights and choose skylight and add a skylight object. And then I'll go and choose mental ray as my renderer. I'll reduce the samples. And I'll go to final gathering for now, although I'm going to work with global illumination in a second. And I'm going to reduce the samples, say to 111, and I'll click on preview. And I'll hit render. So right off the bat, I see that I have the skylight coming in and filling up just the little portion of my entrance. I want the light to globally light the whole hallway with the brightest area from the opening. I'm going to change the background color and set it to pure white. And I want to start working on the brightness of the scene. So the first thing I will do is create an area light that will simulate skylight coming through the opening. Although I do have a skylight object or light here, I still need to create another area light that would be the light source from the opening that will enhance the lighting inside the object, the scene. So if I go to lights and choose mental ray area spot, I can go here and create a light that goes like this. I'm going to go to modify and I'm going to uncheck targeted so that I can move the light without having to worry about the target. I have to keep the shadows set to trace shadows so that I have area lights or area shadows. And I'm going to go down to area light parameters. Here, I need the dimension. I'm going to press P here and go outside. Press Control L to regain my normal display. I need the dimensions of the area light to be the same as the opening here. So I need to increase the height, and the marker that defines the area light should be approximately the same dimensions as the opening. So I'm going to move this up a little bit and go like this. So now I have an area light that fits the opening, which is what I should have. So every time you have a window and you're rendering with global illumination, you should have an area light that shines through, even though you do have a skylight object. This is a requirement when you work with interior scenes like this. So having done this, if I render, I'm still going to see the light shining through the cone. Because even though I have an area shadow, the light is going to be still restricted to the cone. So what I need to do is go to spotlight parameters and increase the hotspot and fall off to the maximum, which is 179.5. That way, the light is going to shine through the plane and not through the limited cone volume. So here, I'm going to bring this and move it to the mouth. And I'm going to press C to go back to my camera view. So let's render now and see what we get. Before we render, though, we have to go down to area light parameters. And here we see that we have the samples value, which is set to 5 by 5. Now, this is not a very good sample value because I have to increase it. But this is going to increase the render time whenever I'm testing. So I have to reduce this to 3 for now, since I'm previewing this. And then I'll increase it in the final render. So now the area light will provide the proper lighting inside the volume. Now, as far as the artifacts go, first, the grain is coming here from the samples of the area light, which are low. The splotches are coming from the fact that I'm using preview mode in Final Gather. So if I uncheck preview mode, these will be reduced or removed. But I still have one problem, which is this. And this is coming from the fact that the area light is casting shadows. So this wall is casting a shadow before the area light, and I'm getting this darkening here, which is not natural. And I should not be getting this. Everything here is all right except for the fact that I have this problem. And the reason I have this problem is that this is not a true area light. Although Mentor calls it Mentor area spot, it's not a real area light. This is a normal light, a point light that generates area shadows. It's not a real area light. So in case I wanted to use this, in this example, I'm still going to get these artifacts, which I should not be getting, or these shadows, which I should not be getting. So this type of light is not suitable for this specific example. For other situations, I'm not going to see that shadow here, and I would use this type of light, as we're going to see later. But for this example, we have to find another way to create area lights. So I'm going to delete this, and instead of using the Mentor Ray area spot, I'm going to go down to photometric lights, and here I have true area lights that I can use with Mentor Ray. These are not native Mentor Ray lights, but they are compatible with Mentor Ray. The one I'm going to use now is the free area light. So I can create the light like this and go to the top view, choose angle snap, and give this a rotation and move this to the back. Now the first advantage for using photometric lights is that, first of all, they are true area lights because they generate light from a surface and not from a point. And then I can go down to area light parameters and I can interactively set the width and height, and I will always see these dimensions on my screen. So at any time, I can see the dimensions of these area lights. So there is my light that I placed here. It should be a bit bigger than the opening. And I'll press C now. Now, this works according to luminance values. But what I'm going to work with is the multiplier, because I'm not going to worry about how many lumens the units of the light are. I'm going to go to multiplier and reduce the intensity by changing the multiplier value. Now, to make this light, area light, compatible with Mentor Ray, I need to go down to area light sampling and make sure that enabled area light sampling is checked. And here I can control the quality of the light. So for now, since I'm testing, I'm going to set this to 8. But in the final render, I'm going to set it to 32 or 64. For now, I'll set it to 8. And I'll give this a render. Now, the purpose here is for the light not to generate actual multiplier intensity. But the purpose is for the light to generate energy of photons so that these photons will bounce around the environment inside the scene and the ambient lighting will be created. So I'm not going to give this any higher values to light up the scene here because I want to generate the lighting from the photons generated by this light. Now, to be able to generate photons, I'm going to go down to where it says Mentor Ray Indirect Illumination. And this is where I work with my photons. So I'm going to go to Render Scene, and I'm going to uncheck for now Final Gathering, and I'm going to go and choose Global Illumination and enable it. Global illumination is the process of Mentor Ray to generate photons, which are light particles, that will go inside the room, or the hallway in this case, and bounce over the walls, and that way generate indirect illumination, and that way I would get my perfect lighting. To make this happen first, I need to visualize the photons so that I can judge on their distribution. I should have a good distribution of photons in case I want to have a good rendering. So I'm going to click on maximum sampling radius, and I'm going to set it for now to 4. This is a testing radius for the photons so that I can see it and therefore judge on the distribution of those photons in my scene. So having done this, I'm going to leave the defaults for now and hit render. So whenever I do this, I start to see these circles, which are the actual photons generated by this area light from here. Now, I have to do a few things for this to work properly. I have to increase the number of photons so that they fill up the surface evenly. And then I have to increase their radius so that they blend together properly, because I should not have dark and bright areas. The blending should be uniform all across the surface, with the mouth part here, the entrance, being brighter than the rest. So, the first thing I'll do is increase the number of global illumination photons. This is a multiplier here that multiplies this value, which is average global illumination photons per light, which is 10,000. So if I go here and type 10, I'm going to have 100,000 photons inside my room. So let's do this and hit render. Now, whenever we did this, the photons appeared to disappear, or they started to disappear. In reality, they did not disappear, but since I have the same level of energy divided over a bigger number of photons, the energy per photon got less. So the brightness of every photon got less. So what I need to do now is increase the overall energy so that I see more brightness in the scene. So this is the energy multiplier, which multiplies this value here. So in case I have 1 and I type 2 here, I'm going to have 2 as a result. So it multiplies the global energy multiplier from here. So let's increase that to 5 for now and give this a render. Okay, so now I start to see more of my photons. I need to increase the energy even more. Let's say 15. So first, I get the photon emission calculation phase, and then I see the rendering. So now I start to see my global illumination effect, which is lighting the whole scene with photons and not with point lights, which is a bad thing. Lighting scenes with point lights would not generate a real lighting environment, because here the lighting is coming through photons which are bouncing over the walls and naturally making the scene brightest at the opening and darker in the back. Okay, so I have a nice photon distribution here. I still need to increase the number of photons a little bit. So let's go to 20 and increase the energy to 25. It's always a testing process. You never have the right amount of photons and energy value from the beginning. You always have to test it until you have the right thing. All right, so it's getting better and better. I'm going to leave it set to here now as far as global illumination number of photons. And I'm going to work on the blending now of the photons so that I don't see any black areas. Now I have two parameters to work with. The first one being the maximum number of photons per sample and the sampling radius. If I decrease the number of photons per sample, say to 1, and render, I'm going to remove all blending from the photons, and they're going to look like distinct little circles, which is not something that I want. This will produce a bad rendering if I decrease this value. So if I increase it beyond a certain level, it will not have any more impact on the quality of the image. So I'm going to set it to 400, or let's say 500, which is the default. And increasing that value beyond this will not give me any extra advantage. So I'm not going to worry about this. I'm going to leave it set to default, because it can blend the photons up to a certain level, and that's it. It cannot override the radius that I have here. So what I really need to work with is the radius value. The bigger the radius value, the more blending between photons. So I'm going to increase that value for now to 15 and hit render. So this took 14 seconds, but when I increase the radius, it's probably going to take a bit more. But now I start to see that I have more blending and more uniform illumination inside my scene. Okay, so this took approximately double the time, which is 28 seconds. But I have to go through this because I cannot render with the small radius photons. And I still have a little problem here. And this is coming from the fact that I'm using low samples for the area light. But this is something that I'll deal with later. Okay, now here I see that I have a little bit of darkening. So I need to fix this before I can continue. So I'm going to uncheck Enable Global Illumination, and I'm going to render without global illumination. So here, what I need to see is some light coming through from this area light. At least some light coming through the opening area. So for that, I'm going to go and increase the multiplier, say to 500, and render. So now, I will back this light to the back a little bit so that I get rid of the artifacts, because these appear whenever the light is too close to the surface, and whenever I pull it back, they disappear. So by moving the light to the back, you get rid of the artifacts. So this is without global illumination. I need to do this before I render with global illumination so that I at least have some direct light coming in through that opening. And the global illumination will take care of the rest. Let's increase this a bit more, say to 700%, which is 7 times more brighter than what we had before. Okay, so this is nice now. I can go back and activate global illumination. Now, since I increased the light here, the energy of the photons might be a bit too much now, which is something that I have to fix. So I go down to energy and I set it for now to 5. Since I have more direct light, the indirect light is going to be multiplied much more. So I would reduce the energy value. Whenever I have overbright areas in my scene, it means that the energy multiplier is not very good, so I have to fix that. But now I start to get some nice results. It's still a bit strong here, so I would reduce the energy, say to 4. But at the end, the final gathering will remove any artifacts generated by global illumination. Now, if I look here, I see that I have bright and dark areas, which is not something good. So I have to increase the number of photons in order to override this limitation. This will take longer to render. For now, I'm going to render as it is, and at the end, I will increase the number of photons so that I would have a more even blending. So let's activate final gathering now. The final gathering will wash out any artifacts from global illumination to produce the final scene. I'm going to check preview, and here I have a fast lookup option. If I check it, I'm going to have, first of all, I have the global illumination phase to calculate. Then I would have another phase, which is the fast lookup phase, and at the end I would have the final gathering phase. So I would have 3 phases to calculate. But if I uncheck fast lookup and I don't activate it, I would have only 2 phases, but the overall rendering will take more than if I did have fast lookup on. So on the final render, I have to check fast lookup because it will speed up the overall rendering. For now, I'm going to uncheck it because I'm still testing. And because I have preview on, I'm not going to have a final gathering calculation phase. It's just going to start to render from the beginning. So as you can see, the final gathering will remove any artifacts, and the result will be very nice with the combination of global illumination and final gathering. The last thing I need to fix are the artifacts, which are generated by the low samples from here. So let's increase the samples for now to 32 and increase the energy a bit more just to have a brighter overall scene. So I'm going to go to 8 and see what I get. Now, of course, when I increase the samples, it will take longer to render. But the shadows will be smooth. Now, 8 gave me a really bright result here, which I might leave or I might reduce. So a value of 6 would probably be a bit better. But the overall illumination is very nice because this part of the sphere is lit indirectly with the global illumination photons. So here it's a bit too bright. So let's go down to 6.5 and increase number of photons, say to 40, and uncheck preview and check fast lookup, and that would be the final rendering for this scene. We want to render this outdoor scene to get a realistic sunlight effect over the geometry. The first thing I'll do is go to renderer. I'm going to set the minimum samples to 1 and the maximum to 4. And I'm going to set the filter type to Lanczos, which will give me a sharp image. If I look at the different filter types, the sharpest is the Lanczos, and then the Mitchell filter, and then triangle, which is a bit blurry. Gauss is blurry and box is blurry. So if you want to create a blurry image, you would use the lower 2 or 3. The upper 2 are the sharpest, the sharper, and the sharpest is Lanczos, which is what I'm going to use now. So if I just render this, I'm going to see a difference with the sharpness of the pixels. So now everything is sharper. And at the end, I'm going to increase the samples to 1 by 16 or 4 by 16. Okay, so far, the scene looks very flat. So we need to add, first of all, a few elements to create depth in the scene and then add the lights. The first thing I'll do is add 2 walls here so that I get a darker corner at this side. So I'm going to go here and create a box that goes up the length. And then I'll create another one here. So this is just to create a shadowed area which will increase the sense of depth in my scene. Since I'm not going to see these objects, I can give them any material I like, preferably a neutral material like light gray. So I'll choose standard and I'll give them a light gray color. So here I made sure that I don't see these in my scene. So first I'm going to go to lights and choose skylight and add a skylight here. And I'm going to go to modify and I'm going to brighten up the skylight color, or actually I'm going to increase the blue value of the skylight color because this is rendered in open daylight. And I like to have the shadows tinted with a shade of blue. So I would choose a nice blue color here, sky blue, and I'll press OK. And then I'm going to choose an inventory area omnilight and shine it down like this. Now I'm going to right click here and choose set view to selected light so that this view goes to the light. I'm going to uncheck angle snap, press V and change the view so that I get the light direction that I'm looking for. So basically I want it to look like a bit like this. I want the shadow to pass through the door here. So I make sure that the whole scene is within the light range, and I fix my view like so. So let's keep it at this now. I'm going to go to modify, and I'm going to decrease the samples for now, just to make the render go faster. And then I'm going to go to the color of the light. I'm going to set the color to something bright, like bright yellow. And since this is open daylight, I'm going to increase the multiplier to 1.3 for now. So let's give this a render. First, we're going to render it without final gathering, and then we're going to use final gathering. So without final gathering, we see that the scene is very dark in the shadowed area. The final gathering will bounce the light inside this area to brighten it up according to the bounces of light, which will make the rendering much more realistic. Alright, so I'm going to activate Final Gather and I'll set the samples to 111 and check preview. And here we're going to look at the maximum bounces in a second. So let's give this a render. If you want to brighten up the dark areas, we have to increase the number of maximum bounces. In case you were using Mental Ray 3.3 and downwards, you don't have this parameter available. So this was added with Mental Ray 3.4 and on. So to brighten up the dark areas, which is the occluded areas with the shadows, I would increase the maximum bounces. I'm going to let this render for a while before I increase that. I like what I have so far. What I need to work on is the darkness in the shaded area. And this is accomplished using two things: the skylight and the maximum bounces. I'm going to increase the maximum bounces to 5 and see what I get. Yeah, I need to lock the camera view so that I render from the camera view. Of course, when I increase the maximum bounces, it's going to take longer to render, but the result will be worth it. So now I don't have total darkness anymore, and I have really good shaded area in this part. Just looking at the pixels rendered so far, I see that it's no longer very dark. And this is because the photons are bouncing in and out over the walls in this area. The last changes I would do for this image is go down to area light parameters and increase the area light height, say to 20 by 20. And then I would have to, because I want to make this shadow go more towards this part, I would have to turn this a little bit like so. Okay. And the last thing I would do is saturate just a little bit more the skylight color and increase the value to 1.5. That will give me an overall coloration for the shaded area.